Students, let us start our second video. This will be about the pressure in fluids, that is liquids and gases. Liquids and gases are called fluids because they can flow. So now how will we see that the liquids and gases also apply pressure? See, in this activity, what do? You take a hollow tube, attach a small balloon at the end, fill it with water. As you can see in this, fill it with water, you will see that the balloon starts bulging out. Why is it bulging? Because water is applying pressure on the balloon. Now if you increase the amount of water here, the bulge in the balloon also will increase. This shows that by increasing the amount of water or the liquid, the pressure also becomes more. The bulging of the balloon was due to the pressure applied by the water. So what do we conclude? That the liquids and gases apply pressure on the containers in which they are stored. Alright, now we will see what are the factors on which the liquid pressure depends. First is the depth. What do you mean by depth? Depth is when we go deep inside the liquid. That is the height. Right? Height and depth means the same. Now in this experiment, you can take any empty plastic bottle or a container, drill 3 holes in it at different levels. There should be equal distance between these two, here and here. Now fill it with water and see how the water comes out from these 3 holes. When you see this, from the first hole, the level of water which is coming out, it is at a low pressure. Then the second one, the pressure increases and it is the highest from the third hole. Why is it so? Because as we go deep inside the water, the pressure increases. So what do we conclude? That the pressure of water or liquid increases with the increasing depth of the liquid. This was the first factor. See, in this also it will be clear that if you fill water inside this, the pressure coming out from these 3 holes of the water will be different. It will be highest in the third case. Now what is the second factor? The second factor is the density of the liquids. What do you mean by density? Now just compare water to honey. If you put some water on the floor, it will take very less time to flow. What about honey or glycerine? It will take more amount of time to flow. Why? Because they are denser than water. They have more number of molecules in their square centimeter. So glycerine and honey are denser than water and corn syrup. These are the different densities of the liquids as they are arranged. Now density is defined as a mass per unit volume. In simple terms, denser liquids have more number of molecules in them in a small space. Understood? The liquids like honey and glycerine are denser, oil is dense, the milk, then water, then ink, they are less intensity. So more the denser the liquid is, the higher the pressure it applies. Understood? Understood all of you? Denser liquids like honey and glycerine will apply more pressure as compared to water and ink or milk. These are the two factors on which the liquid pressure depends. Now, as you can see in this experiment, again you take an empty plastic bottle and make 4 holes, 1, 2, 3 and 1 at the back at the same level. Remember, they all are 3 in the same level. We saw in the first experiment that as we increase the depth, the pressure also increased. But if we make all the 4 holes at the same depth, same level, the pressure of the water coming out from these 3 holes will be the same. Because the depth is the same, the pressure also will be the same. If you decrease the depth, make 1 hole here, the pressure will also increase. And if you make 1 hole above it, the pressure also will decrease. Because the pressure increases with the increasing depth, but at the same depth, the pressure remains the same. Now this is manometer. Manometer is an instrument which is devised to measure pressure. Right? This manometer helps us to see what the pressure is. In the first, you can also make a manometer using a funnel, tie it with a rubber balloon, and these are the 2 ends of a U-tube. Understood? Now difference between this A level and B level will give you the pressure. Understood? So this manometer is used to measure the amount of pressure. Now if the funnel is kept here in the liquid, the pressure will be the same. Even if you keep on shaking the funnel here and there, at the same depth, the pressure will remain the same. But supposing you put the funnel deep inside, the pressure also will increase. How will you measure pressure? The difference between this level and this level will give you the pressure. Right? If you put the funnel here, the pressure will be less. If you put the funnel at the bottom of the beaker, the pressure will be more. The difference will be more. So this manometer is an instrument used to measure the pressure of a liquid. Now what are the characteristics that we have learned about the pressure in liquid? The pressure at any point in a liquid at a particular depth is equal in all directions. then the pressure in liquid does not depend upon the area of the surface. That means the same amount of water in a glass or in a bottle or in a beaker will apply the same pressure. The area does not have any role to play. Then the pressure in liquid acts equally in all directions and does not depend upon the shape of the container. For example, you take a rubber balloon, fill it with water. If you put a hole there anywhere, the same amount of water will come out. It does not depend upon the shape of the container. It only depends upon the depth. As we go deep inside, the pressure increases and the density. Now, what are the consequences of liquid pressure? First, the deep sea fishes are brought to the surface, their bodies burst. Why? Because deep inside the water, the blood pressure of the fishes is also at the same level. But as you come up on the surface of the water, their blood pressure is more. But the pressure of water on the top of the surface of ocean or sea is less. So what will happen? Because of their high blood pressure, their bodies will burst. Deep sea divers, you've seen them wearing specially designed suits when they dive inside the water, is because their blood pressure is less as compared to high pressure inside the water. Inside the water the pressure is high, at the surface of the water the pressure is low. Right? That is the same reason why the hulls of the submarines are especially strengthened. They are very strong because they have to go deep inside the water. Therefore, they have to adjust the pressure accordingly. The same reason the walls of the dams are also specially thickened. Why? Because they have to tolerate the high pressure under the water. As we go deep inside the water, remember, the pressure goes on increasing. Understood all of you? The pressure due to the gases. Yes, the gases like liquids also apply pressure, and they apply pressure on the walls of the container in which they are stored. But otherwise also, if they are present in the atmosphere all around us, there also they apply pressure. Right? You know that atmosphere is a mixture of gases. So the gases present in the atmosphere also apply pressure on us, on everything around us. On everything present on the earth, they apply their pressure. And this is termed as air pressure or atmospheric pressure. How do we define atmospheric pressure? The pressure exerted by the gases present in the atmosphere is called the atmospheric pressure, and its magnitude. As you know, what is magnitude? The strength. The strength or magnitude is around 100 kilopascals at the sea level. Sea level is the ground level. Right? Now 100 kilopascals, how much is 1 pascal? You know that pascal is the unit of measuring pressure. So 1 kilopascal is equal to 1000 pascals. Imagine, so 100 kilopascals will be equal to 100,000 pascals. This much pressure is on our bodies all the time, on everything that is all around us. So why don't our bodies get crushed under such a huge pressure? Is because the pressure inside our body, that is the oxygen and carbon dioxide, the gases are there inside our bodies, they also apply pressure. So this air pressure inside our bodies, it counterbalances the air pressure on the outside, and our bodies do not get crushed. But as we go on higher altitudes, this atmospheric pressure keeps on decreasing. It becomes low and low as we go on higher altitudes. Now what will happen? As we go on higher altitudes, this pressure will become less, and because of that we have to suffer from nose bleeding sometimes, right? And why is it due to? Let us see. First, what is air pressure? It is caused by the weight of the air present all around us. It can change due to the altitudes or the temperature of the air. Now see, this is what I was telling. This is about the consequences of air pressure. People suffer from nose bleeding. Why nose bleeding? Because nose has very small capillaries in which the blood is flowing. Now our blood pressure is at the same level as on the ground level, for example 100 kilopascals. But as we go on higher up, what will happen? Air pressure on the outside will become less than your air pressure inside the bodies. That is why the blood pressure will increase, and our the small capillaries will burst, and we will suffer from nose bleeding. Right? The air pressure is also behind the sucking up of the liquid through the straw. When we suck up liquid through the straw, the air is not there anymore and the liquid rises. The same thing happens in the dropper or the syringe also. When you press the rubber bulb, the air rushes out, and because of the less air pressure, the water can rise. It has nothing to do with water pressure. The air pressure is not there, so the water will rise. Now, you have seen darts. We play with darts. That has a very small rubber thing at the end. That is called a rubber sucker. If you stick it on a smooth surface, it is very difficult to remove it. Why? Because it is called a rubber sucker, because it sucks up the air. Inside the rubber sucker, air is very less. Right? So what will happen? There is no air to counterbalance the very high atmospheric pressure on the outside. So the atmospheric pressure or air pressure on the outside does not let the air's rubber sucker come out. it sticks very properly to the surface and it is very difficult for us to remove it. Only a small amount of air is inside, and so it is not able to counterbalance it. That is why the rubber sucker, it is very difficult for us to remove a rubber sucker if it sticks to a smooth surface properly. If it is rough surface, there might be some air spaces, so air is there to counterbalance. But if it is a smooth surface like a tabletop, like a glass, like very smooth polished wall, then the smoother the surface is, less air spaces are there, and so no air inside, and so atmospheric pressure will not let it come out. Understood? Now we end our topic about the pressure of solids, liquids and gases we have done. I will send you the written work also on the WhatsApp group. Please follow it up. I hope you've understood the topic of today. Enjoy. Goodbye for now.